So hopefully everyone can see my screen. We're going to be actually giving like a condensed lightning talk based on a talk we gave on Monday at Airflow Summit. It was about building data pipelines for data reliability in mind with a set of tools, DataHub, Great Expectations, and Airflow. All right, let's get right into it. So the first thing we're going to talk about is what this concept of data reliability even means and kind of why you should care. So we looked at two definitions when we were thinking about what data reliability means. The first is reliable, which means consistently good in quality or performance, able to be trusted, and reliability, which really means the overall consistency of a measure. And when you think about this applied to data, we think a good way to think about it is really that data reliability is the overall consistency of data quality. Okay, well, that raises a new question. What is data quality? Well, data quality can be thought of as kind of a set of living dimensions. Availability, which just means that data is available for access. Timeliness, which is really about how soon after something happens does the data actually reflect that it happened. So data is typically modeling some events. How long after those events is that updated data ready to use? And then correctness, which is really about does the data accurately represent what it's supposed to be representing? And then data reliability, which can be thought of again as sort of the consistency of data quality over time. So what we're looking at here is something that would be maybe less reliable, where the quality is sort of varying dramatically over time. And this would be something more reliable where the quality is sort of stable and high over time. So two characteristics there, both the consistency and the fact that the quality is remaining high. All right, so thinking about this, how do we realize data reliability? Well, we try to build availability, timeliness, completeness, and correctness into all of our data. But we have to do this across time. So as our ecosystem changes and as our data changes, which as we all know, this is a really tough challenge by itself. And then finally at scale. So we have to do this with maybe thousands of data sets or hundreds of DAGs or even more. And so this is a real challenge. Why should we care about data reliability in the first place? Great question. I think really the strongest reason is that data is becoming a product. And what I mean by that, in practical terms, is that data is now on the kind of value creation chain for many businesses in a very direct way, serving both human and machine consumers. So for example, human consumers, both inside a company or outside of a company as part of a product, and then machine consumers, which again can be internal consumers, or now what we're seeing is companies sharing data and actually building data dependencies across one another, very similar to how many companies have built online dependencies across each other's services. And what that means is that these attributes, availability, timeliness, and correctness, are just going to continue to grow in importance over time. And as a data platform team, there's various challenges we have to face in data reliability. The first is, we've kind of touched on it, scale. Collecting data has never been easier. More people have never been interfacing with digital products than today. The scale of the data we are collecting is just bigger than ever, and it's still growing at quite a clip. And complexity, which is related, right? So as the scale has grown, many organizations have moved towards data democratization, which really means putting this, this volume of data in the hands of their company members to derive insights. And what that's led to is really kind of an explosion of different tools that are very mission built or purpose built for one specific use case on that data value creation capture plane. And these both are changing quickly as well. I think an emergent challenge we face as data platform teams, data engineers, is really like separating the signal from the noise. As we deal with this scale and complexity, as engineers, our typical response is to try to build automation and deal with it using technical solutions. But oftentimes what I've seen and what I've experienced is that this part about filtering is actually one of the hardest pieces. You come in Monday morning and you've got all types of DAGs breaking, and it's really difficult sometimes to understand where to even start given the scale and the volume. All right, now that we kind of understand data reliability as a concept, we're going to talk about building pipelines for data reliability. And we're going to start by looking at kind of some patterns that we've seen in the wild for how people are doing this today. And then we're going to propose a new pattern, which involves obviously DataHub. So let's imagine we have, a simple Airflow pipeline, which produces some output table. We're going to call it table. And it's a pretty standard setup where you have an upstream table that's actually being consumed by multiple downstream consumers. And these downstream consumers, they're owned by different stakeholders. So for example, we have one that produces a derived table. We have another which maybe produces a table that serves as input to a looker chart. And then we have another which maybe generates some emails based on that table. And one key characteristic here is that the producer of the upstream table is independent of the consumers. So there's decoupling between the two. And really, this is the only way that we've seen to achieve scale in data democratization. And the first pattern we've seen, which kind of naturally emerges from this type of architecture for reliability, is what we call consumer-side validation. And what this really is that each of the consumers will basically run some validations or some pre-flight checks on that input table that they're depending on before they run. So for example, this first one may check that input table just exists. And maybe the second one does something a little bit more that says, hey, if the row count in a certain range or a certain timestamp is greater than 0, then maybe I can continue. And maybe the third one just doesn't do any validation at all. It just assumes that upstream table is good to go and then runs. This is what we call contract on read. And what I mean by that is that the contract of the data, not just its structure or the columns and that kind of thing, but the actual kind of row profile as well. So the whole semantic contract of the table is verified by the consumers when they read the data. And there's some different downsides to this approach that we've seen. One is that it's just ad hoc and inconsistent. So, some consumers may only depend on a handful of columns from the table. So maybe they only check that those columns are looking good. Maybe others don't even do any validations at all. There's kind of this partial validation of the contract. And then of course, there's just wastefulness. It's duplicative because you can have multiple downstream consumers that are doing the same processing over and over on this table. The second approach, which I think is a little better, puts a validation of that table in the hand of the producer of the data. And so in this case, what we have is the owner of this transform actually writing some validations against the table and then running them periodically. So for example, you can use tools like Great Expectations or DQ or DBT tests to do things like verify that columns are distinct, not null in a range. Basically verify this semantic contract and then probably do some alerting if they start failing. And this is another very common pattern we've seen. This is what we call contract after write. So once that table has been written, we run some periodic validations on it. And if something is wrong, we send an alert to the owner. Now, there's another downside with this approach. The key downside is that bad data can propagate to all of those downstream consumers by default. There's no way for the consumers to understand that those validations upstream have passed or not. It's kind of up to the diligence of the owner to make sure that they're communicating that. And so we started thinking hey, is there anything we can do better in this type of architecture, just because it's so common across organizations today, particularly those using tools like Airflow. And we started thinking, well, one way would be maybe to push the validation into the right path and actually run validations when the table is generated, let's say on a daily basis. This is what we call contract on write, because when the table is written, we're verifying certain attributes of the table, establishing that it's trusted. And there are upsides to this type of pattern. There's consistency, there's better coverage of the contract because the owner has all of the context of what the table should look like, theoretically being closer to the source. And then finally, it's like a centralized play. We don't have to have the consumers verifying things. But in this approach, there's a few patterns you can use. One is you could fail the upstream DAG if the validations don't pass. Maybe this is running as the final operator in the DAG. Or you could, that's pretty much the main one. But there's not really any way to communicate that that status of the upstream DAG to the downstream consumers. And this is what we call the communication problem. It's really, how do the downstream consumers really know whether the upstream validations passed or failed for a given day? There's not really a clear way to communicate. And so what we're proposing is introducing a metadata platform in between these two decoupled producer and consumers. And what we call this is metadata-driven orchestration. And here's how it works. Basically, as a producer DAG, you kind of add a final step after you've produced a table and run validations, which is called the reporting step. So what you do during the reporting step is you push a signal to DataHub, which basically says, I have produced this downstream table and it has passed or failed its validations. And then what you can do on the other side is add a very thin pre-flight check, which simply checks that the upstream data that it's serving as inputs have indeed passed and are up to date based on the consumer's expectations. So for example, this producer may say, hey, I inserted 45 rows into the table and the table passed its entire validation suite. And then the pre-flight check would ask the same question. Is the input data up to date? Meaning, has it been updated in the last 12 hours? And is it passing its validations or is it failing? All right, and then basically there's kind of two outcomes that we can take. If the checks pass, we can run the pipeline. If they fail, we can circuit break, just to make sure that the bad data is not propagating downstream and we don't have a huge mess to clean up. Obviously, this is a very simple case, but there are cases where there are many, maybe hundreds of downstream looker charts or dashboards dependent on an upstream table. And you can imagine the difficulty and the complexity associated with kind of going up that entire dependency chain and backfilling stuff when bad data makes it all the way down. All right, so a practical example of this, and we're gonna actually continue with what Maggie introduced earlier, this idea of long tail companions, which is a company that, pet adoption company. And we're gonna have a very basic pipeline as an example. We have a set of pet profiles, which is updated from some online store. Periodically, it's ETL'd into S3. Then we have a Snowflake loader, which is going to load this into a Snowflake table. And then finally, we have an email sender job, which is going to send emails to prospective buyers or adopters. And this pipeline is working out pretty well so far. But one day, there's a problem. And that problem is that the pet profiles data is delayed because the ETL job that copies it from online didn't work today. And so what happens? Well, what happens is that the Snowflake table is also delayed, so it's not updated for the day. And our email sender job doesn't know about this, of course, and it still runs. And so what does that mean? Well, it means that we're pushing bad recommendations to prospective adopters. So maybe for pets that have already been adopted. And that's pretty bad because we don't want to pull on their heartstrings or like make our customer support team upset by all of this. So we really want to prevent this type of thing. So we start to think, okay, how can we prevent a situation like this in the future? And this is where the first abstraction provided by DataHub comes into play, which is we're calling DataHub Operations. And the first step of using DataHub Operations is to report when something happens in an upstream DAG. So for example, in that Snowflake loader DAG, we could add a final piece of code that would push that they had inserted 1,000 new rows into pet profiles at some point in time. And then on the other side, we can verify that, of course, but hold your horses on that. We're going to show you how to push this information into DataHub first, and I'm going to pass it over to Tamás to talk about how to do that.
Yeah, let me show you how you can apply this technique to your Airflow pipeline. So for the simplicity, these two DAG will have only one task for each. So even the Snowflake loader and the email sender one. And as well for the simplicity, for both tasks will be a simple bash operator, some kind of daemon bash operator. So for this task, which will be the profilers load, we define inlets and outlets, which is provided by the Airflow lineage API. And we define data sets, like input data sets, which will be here in this case on S3 location, where we load data, which will be the outlet, into Snowflake. And on success, we want to send out operational metadata. And how you send it this operational metadata is pretty easy. We have we basically working on this new API. So first you have to create a DataHub connection, and then you create this operational reporter, and basically you go through all of the outlets and send out operational metadata to DataHub. In this example, we are sending out the operational the earn of the data set, which we would like to send in operational metadata, and the type of operation, which in this case is a insert operation. Of course, you will be able to send out like other informations as well, like partitions, or the number of other metadata, or number of rows affected, and various other key values, key values, what you can imagine or what you want to send out.
Awesome. So once we've kind of posted that to DataHub, we can add a small snippet on the email sender side, which basically just verifies that that information has been reported. And you can do things like verify custom metadata. So as Tamás was alluding to, you can verify that a partition has landed even, or you can verify that the upstream job was a scheduled job versus a backfill job, that sort of thing. And now we'll just look at how you can do that verification.
Yeah, so to protect us from a premature pipeline start, we create for the email sender set up a DataHub operation circuit breaker sensor. It will be a sensor which will be in the beginning of your pipeline. It will be going to check if operational metadata exists, and if and the pipeline continues if there is. So to create it is very easy. You just create a DataHub operational circuit breaker sensor. You basically pass in a DataHub connection, and as well a list of earns, which data set you want to check operational metadata. And also you can set a time delta, which is the time frame where you accept operational metadata. In this case, it's like a 12-hour, because you can imagine you don't want to start your pipeline if you only have data which was created like 2 days ago. This makes sure that your pipeline won't start in this case.
Yep.
Yeah, and of course, yeah, so this is now a sensor, but we are going to provide other Airflow primitives like operator, and also we under the hood, the operator and the sensor as well, using a Python API. And you will be able to use that as well. So in this way, you can basically integrate not just for Airflow, but any other systems as well.
Awesome. And I think we're just going to talk through the demo because we're short on time, but you can imagine you push this data and then you run the downstream and it works or it fails, depending on the presence of the pushed metadata. Okay, so things are running well, but a few months later, we actually have another problem in our pipeline. And in this case, the timestamp column, which we're depending on, has changed from being in seconds to milliseconds because of an upstream change in the online service. Again, you can imagine this is a problem for our email sender job because we're doing a filtering on that timestamp column, and we're actually filtering for profiles that were, recently updated. And so what happens is no emails are sent because now it's in milliseconds, it was in seconds, so our assumptions are broken. Okay, so we've solved the time problem with the operations, but in this case, it's really a correctness problem. It's something about the data itself. And this is where our second abstraction comes in, which is called DataHub Assertions. Some of you may already be familiar or even using Assertions with Great Expectations already. But the Assertions integration basically allows you to run some validation at the end of the producer job, push those validations into DataHub. So examples are, things about the columns, and then again, verify that before the email sender runs. And then we can just zoom through this piece. The first step is defining assertions in something like Great Expectations. In the future, we'll probably support other things like DQ or DBT tests. Once those assertions are run, we push those into DataHub. And of course, some of you may be familiar with this screen already on the right side where we surface the results. And then the final step here is, again, asking DataHub, hey, are my upstream's assertions passing? And are there results that are recent that I should be able to trust? Tamás, you want to talk about this part again?
Yeah, so here in this example for the email sender, we will introduce a DataHub Assertions circuit breaker operator. So as you can see, we provide operators as well. Then basically setting up it's quite similar like how it was like the operational circuit breaker. Basically, you just create a DataHub Assertion circuit breaker operator. You just specify DataHub connection, list of earns, and there is an option which is called like verify after last update, which basically will get the latest operational metadata, and it will check if you have assertion after the latest operation, because we don't want to basically accept assertion which was created before the last update, because most probably it's an outdated data quality check.
All right, so one more demo we're gonna skip. So here we have a few abstractions that help us to work up this pyramid. So we have DataHub operations, which maybe helps towards the availability and timeliness side. And then we have DataHub assertions, which will help more on the correctness aspect of things. I think we're doing an okay job on the through time aspect of reliability, but one thing we haven't really touched on is how to actually do this at scale. So we've instrumented, one DAG, but how do you handle hundreds or thousands of DAGs in your ecosystem? And we started thinking about this and started to think about if there was another solution where we could centralize our control as a central data platform engineering team, and then have distributed enforcement of some policies that we'd like to set about when a pipeline should continue or when a pipeline should be broken. And some key characteristics we were thinking about for a solution here is really, like I mentioned, decoupling that kind of rules definition from the enforcement, which is the circuit breaking in this case. Flexibility, so being able to evolve our rules and our policies of what a good data ecosystem looks like over time. Configurability, so being able to sort of slice and dice for only the most important assets or most important pipelines in our ecosystem so that we can avoid a lot of the noise. Usability, so being able to integrate with all of our DAGs, all of our Airflow pipelines by default without having to kind of go in and instrument them one by one. And what we came up with is a vision for a new feature set, which I think Shashanka mentioned earlier, which is called metadata tests or DataHub tests. And the vision for this feature is really that a data platform team can come into DataHub and they can define or declare a policy inside of DataHub, saying, for example, all tier 1 data sets should have passing assertions. And then 2, we can instrument all of our DAGs to, again, do this circuit breaking check against DataHub before running. And so what this allows us to do is kind of get out of the mode of redefining or reintegrating every single DAG into this DataHub ecosystem one by one. And so how this will work is basically 2 steps. First step is defining a DataHub test. And here's what the definition language will initially look like. It's going to be a YAML file. And there's 2 key blocks I want you to look at. The first is the on block. And that basically filters down the different entities in your metadata graph. So for example, we want to apply a test to all data sets that are tagged with tier 1. And so that's what we're doing in this on block. And the second block is the rules block. In this case, I'm going to run a test that says that the ownership count for these data sets must be greater than 3 because they're maybe important. So that's kind of the first step, is the test definition. Second step is DataHub runs these tests continuously over time on your graph as the metadata changes. And we surface the results of these tests in real time on the entity pages to which they've been applied. So here's what that would look like on the right side. All right, that's great. But again, how do you integrate this seamlessly into your Airflow environment? Tomáš, one more time, can you walk us through this one?
Yeah. So as Joe mentioned, metadata test validation, you don't want to let your DAG owners to basically control if they want to enable or disable it, but you want to make sure it will run for all the tasks in all your DAGs. And actually there is one way to do that in Airflow, which called like cluster policies. If you are not familiar with what cluster policy is, basically when create policies which will do that what I mentioned. So basically will be applied to all of the task in all your DAGs. And we are going to create here a task policy, which basically will get all the tasks, and basically you can mutate all of your tasks with this policy. In this case, we are going to add a pre-execution method to all of your tasks, where basically we are going to run a metadata test circuit breaker. Setting it up, it's pretty easy. Here you will see we are going to use the Python API. You just set up a DataHub connection and then create a metadata test circuit breaker. And then we are getting all the inlets, so the input data sets for your task. And basically we just run the circuit breaker for all of the data sets. And if any data set has a failing test, basically we fail your task. And the cool thing is that in this is that you don't have to change any of your tags or any of your tasks. It will get applied automatically.
Awesome. All right, one more demo we're going to skip. At this point, you're realizing that I am not good at the lightning portion of the talks, mostly just talking. So as we're moving up this pyramid, what we're kind of trying to see here or tell a story about is really preventative metadata. So it's using DataHub's toolkit, including operations, assertions, and now tests to proactively orchestrate your pipelines. And the availability for what we've talked about today, we'll cover briefly. The report operations API, which Tamás was talking about, will come in v0836. I think that's the next one, which is this Friday. The circuit breaker APIs will come in the next release, which is June 10th, I believe. That's going to include the operation circuit breaker. You saw the assertion circuit breaker, the test circuit breaker, and then deep integration with Airflow. So supporting pushing this metadata from sensors or from your operators. And then the test APIs will be coming a little bit later as well in v0837, June 10th. All right, we're going to go through these one more time for fun. All right, and a summary of what we talked about in the talk. Data quality can be thought of as availability, timeliness, and correctness. Data reliability can be thought of as data quality over time. And we presented a new approach to build data pipelines for data reliability or with data reliability in mind, using metadata-driven orchestration. And finally, we talked about a few different tools in the DataHub toolkit, which can help you to start building these pipelines today. Operations, assertions, and tests. All right, and that's the end of our talk.